So this is my completed homework assignment for the Best Robotics Simulink and MATLAB online workshop, class 4. So this is just there's an obstacle environment here, and it's a maze, and the assignment was to essentially use this state flow chart and use it to navigate through the virtual maze. And then after it gets to the middle, let me actually pull up the virtual environment. That way we can take a look at it, and I can better explain what the task was. But as you can see, this here is the virtual environment. Let me pause this for the moment. But the goal is to get the robot let me use the annotate feature here. The goal is to get the robot to go from here, here, go through the maze, stop at the middle, and then turn around and go back. So right now I have it set to infinite. So once it comes back here, it turns back around. But we used temporal logic, so using time. So essentially from here to here is about 70 seconds. So that's why once we go back to my code, I'll show you, or rather my flow chart will show you that, will show you how it does that. So if we go to the state flow chart, you can see that I'll come back to the first block here in a second, but let's look here. So you see how I've said after 70 seconds, we're going to turn around, and we turn for 5.85 seconds and go back to this program where we're trying to navigate through the maze. So in the first program, in the first block that we did here in stage 1, this is what we did in class, where we're moving forward, and depending on the distance, the simulation's running. Let me stop the simulation. So what's happening right now is we're using the distance sensors. If you saw in the Simulink, we're using a front sensor, a left sensor, and a right sensors, and we're using these distance sensors and measuring. And if we're saying the front distance is less than 0.8 and the left distance is less than 0.8, then we're going to turn right, and obviously vice versa, and we're going to turn left. And we're turning for 4.1 seconds and going back. And these are just some of the numbers I've played around with. Same with the 5.85. These are just some of the numbers you have to play around with and figure out. But that's pretty much it for the program. It's a very simple program. It works. There's definitely some flaws and there's ways to improve, but I think it serves the function, the primary function that we needed to. Okay, so there we go. So here's the program, and I will mute myself while this happens, because you don't need to hear me breathing or anything like that while the robot is completing its function. I might provide some commentary in between. Just to reiterate, what it's doing is, as you can see, it's using its distance sensors in the front and the left and in the right. And whenever the front sensor and either the left or the right sensor is less than 0.8, it's turning. So as you can see, it was about to just turn right there, because it measured this wall, and it decided that it needed to turn, and that's what it's doing. So as you can see in the time, we're at about 61 seconds. The idea is once it gets to the middle, it should be about 70 seconds. And as you can see, 67, 68, 69, 70. And now this is where we tell it to turn. Originally, it would have kept turning right, but I told it to turn left at 70 seconds. So that's what it's doing now. And now it's going to measure these walls and try and turn back. So this wall right here, this is where I struggled mainly a lot. There's two portions where I struggled. This portion right here, and then coming back, this portion right here. As you can see, it's very barely just crossing through that. And that's why I had to use the 5.85 second threshold rather than the other thresholds, which is a little difficult to, fine tune, but I think it works, and we're almost done actually. This was another area that I struggled, just trying to get it to turn appropriately right here. Just because now, what I've learned from this is that the more it turns, the more error there is, and the more it starts, not going in the middle, because unless you have a gyroscope sensor, just using time measurements with time can be a little inaccurate, understandably, obviously, but We're almost finished, and we're about to be finished, and that's as far as I could get to. I couldn't get it to touch the wall over there, but that's as far as I could get it to do, just because, once again, it's measuring that wall and wants to turn back around. So I'll stop the simulation here. That's pretty much it for the homework assignment for this class. And obviously, as you can see, I had clicked the arrows, so you could have actually been looking at these values while you were doing that, and you could have also hit navigate maze, and you would have been able to see those as well. That's pretty much it for this homework assignment. And let me know if you have any questions in the comments, or send me an email, or whatever it is. Just find a way to contact me, and I'd be happy to talk about what I did. Hopefully you can teach me if you have anything to teach me, and that would be awesome. Thank you.